Hello, today we will prove Archimedes principle using the Euler's equation. We have to use a vector identity. So let me first state it. Volume integral of grad phi dv equal to surface integral of phi n ds, where phi is a scalar field, v is a closed volume, and s is the surface enclosing the closed volume. Now we start from divergence theorem. Divergence of a dv equal to a dot n ds, and then substitute in the place of a, we substitute phi, which is our scalar field, multiplied with a constant vector, and c is an arbitrary constant vector. Now after we substitute, we get divergence of phi c dv, volume integral equal to phi c dot n ds surface integral. But c is arbitrary, so we can take c out because it's constant as well as arbitrary. So we write c dot volume integral grad phi dv equal to c dot surface integral phi n ds, and then because c is arbitrary, we write volume integral of grad phi dv equal to surface integral of phi n ds. This is equation 1. We are going to use this equation to prove Archimedes principle. Now let us consider a body of volume V immersed in a liquid of density rho. Now let us calculate a small force on the surface of the body, dF, and it must be equal to pressure times area. So P ds n, n is the unit normal from the small area, and minus sign signifies that the pressure force is directed towards inside the volume. So dF vector equal to minus P ds n vector. Now we have to integrate this. From dF vector we get the f vector equal to minus surface integral, then we integrate this, minus surface integral of P n ds. P is pressure field, which is a scalar field. Now we can use our identity, phi n ds equal to grad phi dv. So then we get minus surface integral P n ds equal to minus volume integral of grad P dv. Now we can use the Euler's equation here in grad P, because in static limit grad P is equal to rho g. That is, the pressure force and the gravitational force balance each other. So grad P equal to rho g. So minus volume integral rho g dv. Rho is uniform density of the liquid, so rho goes outside, and g is constant. Of course, acceleration due to gravity also goes outside the integral. So just volume integral of dv, which is the volume. Now let us rewrite. The buoyant force now becomes, then the buoyant force becomes F equal to minus rho g, because rho and g has gone out of the volume integral, and volume integral dv, so it is minus rho g v. So you can write minus g times rho v, so it is minus g times mass of the displaced liquid. So buoyant force is given as minus g times mass of the displaced liquid. So it is directed the upward direction because of this minus sign. That is why it is buoyant. And the magnitude of the force is equal to the mass of the displaced liquid multiplied by g, that is weight of the displaced liquid. So this is the Archimedes principle, and we know it from our childhood. But here we have proved it using this vector identity, grad phi dv equal to volume integral of grad phi dv equal to surface integral of phi n ds. This is one. And Euler's equation in static limit, which says that the pressure force and the gravitational force balance each other in the static limit. So I hope you have found it interesting, and thank you for watching.